think back to your last really frustrating online login. You know the exact scenario I'm talking
Oh,
about.
definitely. We've all been there.
Right. You type in your password, you hit enter, and suddenly you are just squinting at this grid of blurry, like incredibly low-resolution photos.
Desperately trying to identify every single square that contains a crosswalk.
Yes. Or maybe it's a motorcycle. Or you get that audio challenge where you're trying to decipher these totally garbled numbers.
Through what sounds like a broken radio in a wind tunnel.
Exactly. It's miserable. And we put up with this daily friction. We just accept it because there was this fundamental assumption baked into the whole experience.
That it's keeping you safe.
Right. You assume this annoying little puzzle is like a concrete wall, that it's keeping the bots out and keeping your bank accounts, your emails, basically your whole digital life secure.
It is a really comforting assumption. I mean, the idea that performing a distinctly human task acts as this impenetrable shield against automation.
But the data from the front lines of cybersecurity tells a completely different story now, doesn't it?
Oh, a wildly different story. Yeah.
So in this deep dive, we are going to explore how artificial intelligence hasn't just, cracked the candy TCHA. It has completely dismantled it.
Totally torn it down.
We're going to look at the sprawling and honestly surprisingly cheap, dark economics of the bypass industry and how security engineers are just desperately trying to build an entirely new defensive playbook.
Because the old one is completely obsolete.
Right. And our guides for this are two really highly detailed sources. We have this fascinating proof of concept write-up by a security researcher who built a totally free local bypass tool.
And that's paired with a massive deep research report that details the whole commercial CAPTCHA bypass ecosystem and the modern defense strategies.
So let's start with that proof of concept, because it's a great starting point just for its sheer elegance.
It really is. I mean, the researcher didn't rent out some massive server farm. They didn't use million-dollar supercomputers or anything.
No, they built a fully automated pipeline using just 3 open-source tools.
Right. To turn that concrete wall we talked about into basically a 0-second, $0 automatic door.
So let's break down those tools. If they're using Playwright for the automation, that means they're running a headless browser.
Exactly.
Which is essentially an invisible ghost in the machine that navigates the DOM directly. But I mean, throwing a heavyweight vision model at every single login attempt just to solve visual puzzles, that sounds incredibly resource intensive.
And slow. It would be super slow.
Right.
But the researcher bypassed the visual element entirely. They designed the script to explicitly trigger the audio challenge instead.
Oh, that's clever.
Yeah. So when the target page loads, Playwright doesn't even try to solve the image grid. It just hands control over to Alibaba Page Agent.
Which is an LLM.
Right, an LLM specifically optimized to understand web page structures and visual hierarchies.
Okay, so instead of writing brittle code targeting specific CSS selectors, which, they break the second a developer changes the button's class name, the LLM just processes natural language.
Exactly. You just give it the instruction to find and click the play audio button.
And it just knows what that means. It understands the semantic layout of the page.
It does. And once Page Agent locates and clicks that audio button, Playwright does something really interesting. It intercepts the audio data packet at the network layer.
Wait, like split seconds before it would ever reach a physical speaker.
Exactly. It grabs it before the sound even exists, really. And it hands that pristine audio file directly to an ultra-lightweight local instance of OpenAI's Whisper model.
Which means no cloud API calls,
None.
no latency,
Yeah.
and absolutely zero costs.
$0. Whisper just transcribes the spoken numbers right through the deliberate background noise. Playwright injects the digits into the input field, and bam, the bot is logged in.
All happening in a matter of seconds.
Milliseconds, sometimes.
It fundamentally changes how automated attacks work. I mean, it's like taking a blindfolded person who previously navigated a maze by memorizing the exact number of steps.
Like walk 5 paces to the login div.
Right. Turn left at the sound button class.
Yeah.
And instead, you're just taking their blindfold off. The bot opens its eyes, looks at the page, sees a speaker icon, and clicks it.
Which means the old defense of DOM obfuscation, scrambling your website's code to confuse bots, is completely useless now.
Because it's up against a model that understands semantic meaning. It just looks at it like a human would.
Exactly. And that semantic understanding is incredibly robust. Though, the researcher did hit one fascinating technical hurdle with this that I love.
Oh, yeah, the Korean language quirk.
Yes, it really highlights the strange realities of working with AI models.
Walk us through that, because it's pretty funny. The researcher triggers a Korean audio challenge, right?
Right, and the CAPTCHA voice says a string of numbers in Korean. But Whisper, in its attempt to be super helpful, transcribes the audio into this weird phonetic mix of Korean words and Arabic numerals.
So it outputs something like the Korean word for 8.
Eh.
Right, followed by the digits 2 and 0.
Exactly. And the problem arises when that transcript hits the traditional sanitization code that developers use.
Because they usually just run a basic regex to clean up transcripts before submitting them.
Right. And that regex is programmed to simply delete anything that isn't an Arabic digit from 0 to 9.
So the regex sees the Korean word for 8, assumes it's just garbage text, and completely deletes it.
Yep. So the bot submits 20 instead of 820, and the whole login fails.
Which is such a weird edge case. The researcher had to build a custom mapping table just to manually translate the quirks of AI hearing.
They had to account for every Korean number word, plus the weird phonetic mistakes Whisper naturally makes, like confusing the Korean word for 0 with the word for bread.
Which is amazing, just to force the model to spit out a clean string of digits.
It just proves that, weaponizing AI still requires an engineer to smooth out the edge cases.
Sure.
But once that mapping table is in place, the pipeline runs flawlessly forever.
Okay, so audio CAPTCHAs are clearly vulnerable because they rely on intercepting the sound file. But visual challenges force the bot to actually render the grid and interact with the UI.
Right.
That structural difference has to make visual puzzles harder to automate, doesn't it?
Well, you'd really think so, but the broader Deep Research report catalogs this vast open source arsenal on GitHub that proves otherwise.
Wow.
Literally every single type of CAPTCHA has a free bypass available right now.
Even the visual ones.
Especially the visual ones. There's a tool called CAPTCHA Bypass that plugs directly into the vision capabilities of models like GPT-4o or Gemini.
So you just feed it the blurry grid.
Yeah, you feed it the grid, and the LLM instantly maps the motorcycles or the crosswalks. It is virtually flawless at object recognition.
Okay, what about the slider puzzles? The ones where you have to drag a puzzle piece into a little cutout? I mean, honestly, even I struggle to drop those in the exact right spot.
I know, they're annoying. But the AI actually has a massive advantage there.
Really? How?
The tool takes a screenshot of the puzzle, and it uses the vision model to calculate the exact mathematical pixel distance between the piece and the hole.
Oh, wow.
Yeah, and then it just executes a programmatic mouse drag to drop it in perfectly. Every single time.
Okay, I have to point out the tragic irony of this entire ecosystem, which is perfectly captured by one specific repository in that report.
Oh, the Google one.
Yes, Google reCAPTCHA Bypass. If a bot triggers the audio version of Google's reCAPTCHA, this tool downloads the audio file and sends it directly to Google's own enterprise speech-to-text API.
It is brilliant and terrifying.
It literally uses Google's commercial AI transcription service to perfectly defeat Google's own security puzzle, usually in under 5 seconds.
It's the ultimate asymmetrical arms race. Enterprise productivity tools are just instantly weaponized against enterprise security systems.
It's hilarious, honestly. But wait, let's look at the behavioral analysis side.
Okay.
Because Cloudflare Turnstile and Google's reCAPTCHA v3, they don't even show you a puzzle most of the time.
Right, they're invisible.
They just sit in the background and monitor how you move your mouse, how you scroll your typing cadence. And bots are perfectly precise, right? They click the dead center of a pixel instantly.
Yes.
But humans are chaotic. We jitter the mouse, we pause, we scroll past the button and then have to scroll back. Shouldn't behavioral analysis catch the bots, even if they can solve the underlying puzzle?
Well, behavioral analysis is designed to be that ultimate trap. It's supposed to catch the precision you just mentioned.
Right.
But the open source community adapted. They started building stealth browsers. The report highlights tools like Turnstile Solver, which rely on heavily modified browser frameworks.
Like Playwright or Camofox.
Exactly, and these aren't just your standard headless browsers.
They actively spoof their own environment.
Far beyond simple spoofing. I mean, they are engineered from the ground up to lie to the target website.
How so?
They strip away all the automated signals, they spoof canvas fingerprinting, they even fake the way your graphics card renders WebGL imagery so it looks like a standard, everyday consumer GPU.
That is wild.
And crucially, they mathematically simulate messy, chaotic, human-like mouse trajectories.
So they intentionally act drunk to get past the bouncer.
That is exactly the mechanism. If the defense relies on spotting robotic precision, the stealth browser mathematically generates human imperfection.
It adds the jitter.
The jitters, the micropauses, the curved mouse arcs, everything. You just can no longer rely on behavioral analysis alone because the bots mimic our messiness at the algorithmic level.
But wait. Running a fleet of heavily modified stealth browsers with local whisper models, DOM-parsing LLMs, and proxy networks, that takes serious orchestration.
And technical overhead, yeah.
Right. Most threat actors aren't spinning up complex Docker containers just to check a few thousand stolen passwords, are they?
No, and they don't have to.
Because they just buy it.
Exactly. The technical barrier to entry is completely irrelevant now because of the massive, dark economic engine driving this whole thing.
The bypass industry?
Yeah, it operates like any other software as a service market. The Deep Research Report breaks this down into two distinct commercial tiers.
Okay, let's go through them.
Starting with human solver farms.
Services like CAPTCHA and anti-CAPTCHA. But wait, these aren't using AI at all, are they?
Not for this tier, no. These are registered businesses operating massive digital sweatshops.
Wow.
They primarily employ people in developing nations to just sit at screens and manually solve puzzles all day. I mean, anti-CAPTCHA openly advertises that their solves are 100% human-powered.
And the pricing listed in the report is what truly breaks the defense model for me. An attacker can buy a block of 1,000 successful human solves for between 50 cents and $2.
It's literally a fraction of a penny per hack.
That entirely inverts the economics of cybersecurity.
It really does. And then, for the high-end attackers who don't want to integrate a solver farm or manage their own stealth browsers, there is the second tier.
The unblocker APIs.
Right. Tools like Bright Data or Zeit.
What do they do differently?
These APIs bundle the entire art of breaking into a website into a single endpoint. You just send a request, and they handle the CAPTCHA solving, the stealth browser anti-fingerprinting, and most importantly, the proxy rotation.
Routing the attack traffic through residential IP networks.
Yes. So instead of the target server seeing 1,000 login attempts all coming from a single AWS data center.
Which is obvious and easy to block.
Exactly. Instead of that, the Unblocker API routes the traffic through compromised smart TVs, home routers, and IoT devices in everyday homes.
So the server just sees 1,000 distinct, clean residential IP addresses.
Yep. And the Unblocker APIs charge around $1.50 per 1,000 successful bypasses, and they use a success-only billing model.
Meaning, if the API hits a wall, the attacker pays nothing.
Zero financial risk.
Unbelievable. And synthesizing this with the academic timeline in the report, it really shows that none of this should be a surprise to the industry.
No, academia has been warning us for over a decade.
Right. Back in 2010, Motoyama's paper thoroughly documented the robust business model of those human solver farms.
And by 2017, the UnCAPTCHA paper at Usenix demonstrated they could beat Google's audio challenges with 85% accuracy.
Which prompted Google to adapt, right?
Yeah.
They switched from spoken numbers to spoken phrases.
They did, but it was just a temporary fix. By the 2023 NDSS Symposium, researchers were hitting 98.3% accuracy against audio CAPTCHAs.
Just using off-the-shelf commercial speech recognition.
Exactly.
Yeah.
The structural vulnerability of audio challenges to speech AI has been an established fact in academia for years.
Which brings us to a massive contradiction that I want to unpack.
Okay.
If unblocker APIs are routing attacks through millions of different residential IPs, traditional rate limiting is completely dead.
Right.
You can't block an IP address if it only tries one password and then moves on.
Exactly.
So if the puzzles are broken, human farms cost pennies, AI mimics our behavior, and rate limiting is useless.
Yeah.
How are secure systems actually keeping our accounts safe today?
Well, the short answer is that the textbook defense advice has completely failed.
Because of credential stuffing.
Yes. Attackers take databases of millions of known usernames and passwords leaked from other breaches, and they try each combination exactly once across those distributed IPs.
So they never trip the alarms.
Never. That's why NIST and OWASP guidelines now explicitly classify CAPTCHAs as mere friction. They are not a standalone defense anymore.
So what's the new playbook? Because they must be doing something.
The modern playbook assumes the CAPTCHA will be defeated. It relies on a multi-layered post-puzzle strategy. The report outlines this in steps.
Steps 1 and 2 are essentially what they call advanced friction, right?
Right. There are ways to degrade the AI's efficiency. For audio, you inject adversarial noise.
Like complex static, echoes, overlapping frequencies.
Exactly. A human brain can naturally filter that out, for the most part, but it mathematically disrupts the waveform analysis of an AI transcription model.
It causes it to hallucinate.
Yep. And you also enforce strict session limits. You restrict how many times a single browser session can request a new audio challenge.
To prevent bots from endlessly refreshing until they get a clean audio file.
Exactly.
But the AI models are constantly being trained to ignore that adversarial noise. It's a game of whack-a-mole. So if attackers are using credential stuffing, the logical step 3 is to neutralize their ammunition.
Right. You stop the leaked passwords at the front door.
How does that work in practice?
You integrate the authentication flow with services like the Have I Been Pwned API.
Oh, right.
So when you enter your credentials, the server hashes the password and instantly checks if that hash exists in known breach databases.
And if it does?
The server rejects the login, even if the password's correct for that account, and it forces an immediate password reset.
But threat actors routinely use fresh, unindexed breaches. If the hash isn't in the database yet, the bot gets right through.
Which is why we desperately need step 4, post-login paranoia.
Post-login paranoia. I love that term.
It's exactly what it sounds like. You have to assume the bot successfully solved the puzzle, bypassed the behavioral checks, used a valid unbreached password, and is now inside the account.
Okay, so they're in. What then?
At this stage, the defense pivots to monitoring telemetry. Think about it. A human logging into a hotel rewards account takes time, right? They wait for the UI to render, they scroll through their profile, they navigate the menus.
Yeah, we're slow.
But a bot executing an account takeover, it instantly hits the points balance API, scrapes the raw numerical value of the rewards points, and terminates the session in like 1.2 seconds.
Because it's just pure inventory management for them?
Yeah.
The bot is just checking if the account has enough value to resell on the dark web.
Exactly. So modern security systems monitor for that hyper-efficient, non-human telemetry. If an account logs in, hits a sensitive API endpoint, and vanishes faster than a human could physically move a mouse.
The system freezes the account.
Boom!
Frozen.
Okay, so we have adversarial noise, breached hash checking, and post-login behavioral paranoia. But the report clearly points to step 5 as the ultimate permanent fix.
Passkeys. The FIDO2 standard,
Right.
it really is the only structural solution left. FIDO2 eliminates the password entirely using asymmetric public key cryptography.
So the server only holds a public key, like an open padlock, while your physical device, like your phone's secure enclave, holds the private key.
Exactly. When you log in, the server sends a mathematical challenge, and your device signs it using your biometric approval, like Face ID or a fingerprint.
So there is no shared secret.
None. The server doesn't store a password that can be stolen, meaning a breach of the company's database only yields completely useless public keys, which is huge. If passkeys rely on asymmetric cryptography where there is no shared secret to steal, credential stuffing is rendered mathematically impossible.
You can't stuff what isn't there.
A bot cannot buy a database of your hardware's private keys. But, and here's my pushback, if step 5 solves the problem permanently, why are companies wasting millions of dollars in endless development cycles on steps 1 through 4?
It's a fair question.
Why not aggressively mandate passkeys today and just kill the password entirely?
Because the technical theory is flawless, but the reality of global infrastructure is deeply, deeply messy.
Meaning?
Mandating passkeys overnight would lock out millions of legitimate users. People who rely on legacy hardware, older operating systems, or people who just simply refuse to adopt biometric authenticators. Transitioning billions of users to a passwordless standard requires an immense cultural and technical shift. Steps 1 through 4 aren't the solution.
A bridge.
They are the critical life support keeping the digital economy functioning while that generational transition takes place.
Wow. So we are really just stuck in this transitional era.
We are.
I mean, we've seen how open source tools like Playwright and Whisper have turned the CAPTCHA from a concrete wall into, at best, a minor speed bump.
Barely even that.
AI can read distorted text, listen through adversarial noise, and mathematically simulate the chaotic precision of a human hand.
Perfectly.
And driving all of this is a sprawling, dirt-cheap economy of human solver farms and unblocker APIs that route attacks through residential networks, turning complex security bypasses into just a simple line item on a hacker's budget.
Right. Defenders have basically accepted that the puzzle is broken. The battle has entirely shifted to analyzing the context of the login, validating the integrity of the credentials, and monitoring the speed of the session after the door is already open.
Which leaves you with a really fascinating dilemma to consider. Because for 2 decades, we have been forced to prove our humanity to computers by deciphering noise and picking out traffic lights. Now, the industry is moving to passkeys, essentially outsourcing the proof of our identity to the biometric sensors and hardware enclaves on our physical devices.
True.
But as AI models become more sophisticated, how long will it be until malware learns to bypass the camera and microphone entirely and starts piping deep-fake biometric signatures directly into the hardware enclave itself?
Oh, that is absolutely the next frontier of the arms race.
The future of internet security isn't about proving you are human anymore. It's about proving your hardware isn't hallucinating.
Exactly.
Thanks for joining us on this deep dive. Until next time.